Well, hello geometers and general seekers of truth. In this video, we continue our work with triangle similarity, and we learn one more new theorem here. This is called the side angle side similarity theorem. And I say this, I emphasize similarity here because there is a congruent there is another side angle side theorem that is not really related to this one. So just want to make sure that we are all on the same page. This theorem here, we are talking about similarity of a triangle, not triangle congruences. And yes, that brings me to my other point. We are talking about triangles here, not any other shape. There are such things as similar quadrilaterals, similar pentagons, similar hexagons, and so many others. But in this video, we concern ourselves with triangles only. So let's get right to it. Let me give you a quick example. So suppose I have a triangle that looks something like this, and this length here is 3, and this length here is 5. And we will call this triangle ABC. Okay, kind of an unimaginative name, but we'll go with that, triangle ABC. Let's clean up this corner just a little bit here. Triangle ABC. All right, and let's try another shape here. Also a triangle. And let me do this a little bit better. See if I can do this better here. So let's say there and there. All right. We'll call this side, let's say that this side length is 10, and this side length here is 6. And we'll call this triangle DFG. Okay. So far, all I have here are two proportional sides. I hope you can see that 3 and 6 have a ratio of 1/2. 5 and 10 have a ratio of 1/2. Now, if you remember from our previous video, that's not enough, right? Remember? Let me scroll back up here to the previous stuff that we were talking about. So these triangles up here, we were trying to determine whether or not they were similar. And we said that the blue one and the green one, that's the stuff down here, we checked two of their sides and they were proportional. But the third side wasn't proportional. So let's get back to this example. Well, if there's only two sides that were proportional, we can't say that. But this is called the side angle side. If an angle of one triangle is congruent to the angle of a second triangle, and the lengths of the sides, including these angles, are proportional. So if I were to add an extra piece of information, like angle A is congruent to angle F, okay, so now I have one congruent pair of angles, I should say, and the two sides that are including that angle, 10 and 6, 3 and 5 here, are proportional, then now it is enough for me to conclude that triangle ABC is similar to, and I have to be super careful how I say this other side, AB is the side length that's 5. So I have to go with DF. Nope, I actually don't want to do that. AB is the side length that's 5. BC is the unmarked side. So I have to do the same thing here. FD is the side that matches up with AB. 10 is proportional to 5 in this case. Or the proportion used is 10 and 5. And then DG is the side length that's unmarked. So it's triangle FDG. So if I have two sides that are proportional and the angle in between them are congruent, then that's enough for us to say that the two triangles are similar to each other. Alright, so we'll go on to the next video and we'll discuss and we will work through many more examples in greater detail. Thank you for watching and have a